Graphs of sines and cosines. A periodic function is a function f such that f of x equals f of parentheses x plus np for every real number x in the domain of f, every integer n, and some positive number p. The least positive value of p is the period of the function. The circumference of the unit circle is 2 pi, so the least value of p for which sine and cosine functions repeat is 2 pi. Therefore, the sine and cosine functions are periodic functions with a period of 2 pi. To find the period for b is greater than 0, the graph of y equals sine of bx will resemble that of y equals sine of x, but with the period of 2 pi divided by b. Also, the graph of y equals cosine of bx will resemble that of y equals cosine of x, but with the period of 2 pi over b. The amplitude of the graph of y equals a sine of x or y equals a cosine of x with a not equal to 0 will have the same shape as the graph of the y equals sine of x or y equals cosine of x respectively, except with the range from negative absolute value of a, comma, a. The amplitude is the absolute value of a. Putting this all together, the graph of y equals a sine parentheses bx minus c, where b is greater than 0, is obtained by the horizontal shift of the graph of y equals a sine of bx, so that the starting point of the cycle is shifted from x equals 0 to x equals c divided by b. Notice where the c and b is. If c divided by b is greater than 0, the shift is to the right, and if c divided by b is less than 0, the shift is to the left. The number c divided by b is called the phase shift. The amplitude is the absolute value of a, and the period is 2 pi over b. The graph of y equals a cosine parentheses bx minus c is obtained horizontally, shifting the graph of y equals a cosine of bx so that the starting point of the cycle is shifted from x equals 0 to x equals c divided by b. If c divided by b is greater than 0, the shift is to the right, and if c divided by b is less than 0, the shift is to the left. The number c divided by b is called the phase shift. The amplitude is the absolute value of a. The period is 2 pi divided by b. For sine graph of form y equals a sine of parentheses bx minus c close parentheses plus d and y equals a cosine parentheses bx minus c close parentheses plus d, the constant d causes the vertical shift in the graph. These vertical shifts result in the sine graph oscillating about the horizontal line y equals d rather than about the x-axis. So the maximum value of y is d plus the absolute value of a, and the minimum value of y is d minus the absolute value of a. Guidelines for sketching the graph of sine and cosine function. Method 1. Follow the steps. Identify the amplitude and the period. Find the value of x for the 5 key points, starting with the value of x where the cycle begins and adding a quarter, that is, a period divided by 4, to find the next x value, and so on. Step 3. Find the values of the y for those 5 key points. And then step 4, we're going to connect the 5 key points with a smooth curve and graph one complete cycle, and then we'll draw the graph over additional periods as needed. So you would continue the pattern in that format. So we're going to draw the basic function y equals sine of x. We're going to identify the amplitude. The amplitude is always the number in front of sine of x that's being multiplied. In this case, it's 1. So the absolute value of 1 is 1. Notice this problem can be rewritten as y equals 1 sine of 1x. So here the period is going to be 2 pi divided by my b. Well, my b here is 1. So 2 pi divided by 1 is 2 pi. Next, we're going to find the values for the 5 key points. To do that, we're going to take our period and divide by 4. So we're going to take our period, which is 2 pi, and divided by 4. So I'm basically counting by, if I simplify this fraction, I'm basically counting by pi over 2. And since we don't have a phase shift here, we're actually graphing this, because the period is 2 pi, we're actually graphing it from 0 to 2 pi. That's my interval. So we're going to go through, and my first x value will be 0. My second one will be 0 plus pi over 2, which is pi over 2. Notice I'm counting by pi over 2. My third point will be pi over 2 plus pi over 2. Well, 1 pi plus 1 pi is 2 pi over 2, which is just pi. Once again, I am basically adding pi over 2 each time to get the next x value. My fourth x value will be, I'm going to keep the 2 pi over 2 plus the pi over 2, since it already has a common denominator. That'll give me 3 pi over 2. And then we have 3 pi over 2 plus pi over 2. That's 1 pi over 2. So that's 4 pi over 2, which is 2 pi. So notice I started at 0 and I stopped at 2 pi, so I know I have my points correctly, my x values correctly. Now we're going to find the points by just substituting. So we have my y value, my function is y equals sine of x. So sine of 0, if you use the unit circle, sine of 0 is 0. Sine of pi over 2, sine at pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi gives me 0. So notice this gave me my 3 x-intercepts. And what I also know is my max value and min value. And the max and min value is from the amplitude. Notice the amplitude was 1, so the max is 1 and the min is negative 1. So I'm just going to kind of sketch my y-axis. And I'm going to label my points. So this is 0, 0. My next point is pi over 2, 1. My next point is pi 0. Notice I'm just counting by pi over 2. Each little space is pi over 2. My next point is 3 pi over 2 negative 1. And my last point is 2 pi comma 0. Notice that the graph of the sine function starts at the x-intercept, then it goes to max, then x-intercept, then to min, to the x-intercept. So I kind of call my x-intercept my base. So it goes base, max, base, min, base. Now, the base is always going to be 0 unless we have some kind of shifting going on, which is going to be the vertical shift. Graph y equals cosine of x. We're going to identify the amplitude. Notice the number in front of cosine of x is understood 1. So the absolute value of 1 is 1. That tells me that the max is 1 and the min is negative 1. The period is going to be 2 pi. over b, which is 1 in this case, so it's just 2 pi. Once again, this graph is going from 0 to 2 pi, that's 1 period. Find the value of the x points. Well, to find the values, we're always going to take the period and divide by 4, so that's 2 pi over 4, or pi over 2, so we're basically counting by pi over 2 in each one starting at 0. So we're going to start at 0, and 0 plus pi over 2 is pi over 2. Pi over 2 plus pi over 2 is 2 pi over 2. I'll wait to simplify. 2 pi over 2 plus pi over 2 is 3 pi over 2. 3 pi over 2 plus pi over 2 is 4 pi over 2. So when I simplify 2 pi over 2, that gives me pi, and when I simplify 4 pi over 2, that gives me 2 pi. Notice I started at 0 and I stopped at 2 pi. That's 1 period. Okay, so now we have y equals cosine of x is my y value, so cosine of 0 is 1. Cosine of pi over 2, I'm using the unit circle, cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0, and cosine of 2 pi is equal to 1. So notice my maximum is 1. My minimum is -1. That comes from the amplitude. And then here my x-intercept is pi over 2, 0, and 3 pi over 2, 0. And remember I said I call that base just in case there's shifting going on. So the pattern for cosine is going to be max, base, min, base, max. So it starts at max and ends at max if you did it all correctly. So I'm going to graph this one. If I just label the x-axis, I can count by pi over 2. So there's pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and then 4 pi over 2, which is 2 pi. Notice we were counting by pi over 2. Each little space is pi over 2. This is just 1 period. We would continue in that manner if we were doing 2 periods. My max is 1 and my min is -1. So we have my first point at 0, 1. Then pi over 2, 0. Then pi -1. 3 pi over 2, 0. 2 pi, 1. And this is almost like a nice curve. It looks like the parabola, but makes it a nice curve. It's not like a V. Next, we're going to graph y equals 4 sine of x. So we're taking the basic y equals sine of x, and now it says y equals 4 times sine of x. So what does that 4 do? Well, that changes the amplitude and changes how high and how low this graph is going. So the absolute value of 4 is 4. So the highest is going to be is 4, and the lowest is going to be is -4, or the minimum. The period is 2 pi over b, which in this case, b is just, since it's 1x, it's just 1. So that's 2 pi. So my interval is going to be between 0 and 2 pi. So we're going to start at 0 and we're going to stop. Step 2, we're going to find the values of x for 5 key points. Well, it's going to be period divided by 4. So in this case, it's 2 pi divided by 4, which is pi over 2. So I'm counting by pi over 2. Starting at 0, so my first x1 is 0. The second one is 0 plus pi over 2, which is pi over 2. Then we have 1 pi over 2 plus pi over 2, which is 2 pi over 2. 2 pi over 2 plus pi over 2 is 3 pi over 2, and 3 pi over 2 plus pi over 2 is 4 pi over 2. Notice I'm not simplifying my fraction till the end. Sometimes that helps, just because make sure when we add and subtract, we have a common denominator. In this case, since I already had it, I didn't want to simplify till the end. All right, so now we're going to find the y values. And to find the y values, this is going to be y equals 4 times sine of x. So here, my first one we have is 4 times sine of 0. Well, we know sine of 0 is 0, and 4 times 0 is 0. You can use a calculator to make sure you're in mode of radians. The next point we have is 4 sine of pi over 2. We know sine of pi over 2 is 1. 4 times 1 is 4. 4 sine of pi. We know sine of pi is 0, so 4 times 0 is 0. The next one is 4 sine of 3 pi over 2. Sine of 3 pi over 2 is -1. 4 times -1 is -4. And the last point is 4 sine of 2 pi. Sine of 2 pi is 0. 4 times 0 is 0. So once again, we have my bases. Remember the pattern for sine is going to be my base, or my x-intercept in this case. And then it goes to max value. Then it goes back to base, or my x-intercept in this case. Then it goes to min. Then it goes to x-intercept. So this one I'm off a little bit. I could count by 2s, but I want to show you what the amplitude of 4 does. So we're just going to kind of increase it a little bit. And I'll just go down on the graph just a little bit. Okay, so my first point is at 0, 0. My next point is at pi over 2, 4. My next point is at pi 0. My next point is 3 pi over 2, -4. And my last point is at 2 pi 0. So when I connect this, here is 0, 0, to pi over 2, 0, to pi 0, to 3 pi over 2, -4, and then 2 pi 0. So notice that all it did to the basic sine function graph is that the amplitude, the max and min, now the max is 4 and the min is -4. We're going to graph y equals -3 cosine of x. Once again, the amplitude here is the absolute value of -3, which is 3. The period is 2 pi divided by 1, which is 2 pi. So in this case, once again, because there's no phase shift, we're going from 0 to 2 pi. So we're going to start at 0 and stop at 2 pi. And we're going to find the values of x by saying the period divided by 4. So that's 2 pi over 4, which is pi over 2. So we're counting by pi over 2 each time, starting at 0. So we have 0 plus pi over 2, which is pi over 2. Pi over 2 plus pi over 2 is 2 pi over 2. 2 pi over 2 plus pi over 2 is 3 pi over 2. And then 3 pi over 2 plus pi over 2 is 4 pi over 2, and then I'll simplify. This time, my function is y equals -3 cosine of x. Let's see what that negative sign does to this problem. We already know that the amplitude is 3, so the max is 3 and the min is 3. So my first one we have is negative 3 cosine of 0. Cosine of 0 is 1, so negative 3 times 1 is negative 3. Negative 3 cosine of pi over 2. We know cosine of pi over 2 is 0, and negative 3 times 0 is 0. I'm using the unit circle once again. Negative 3 cosine pi. Cosine of pi is negative 1. Negative 3 times negative 1 is 3. The next point, negative 3 cosine of 3 pi over 2. Well, cosine of 3 pi over 2 is 0, and negative 3 times 0 is 0. The next one, negative 3 cosine of 2 pi. Cosine of 2 pi is 1, and negative 3 times 1 is negative 3. So notice when I pointed out earlier that cosine usually starts at max and ends at max. Well, in this case, because it had that negative sign, it has a reflection. So it starts at min and it stops at min. So we have our first point being 0, negative 3, which is a min value. Then we have our x-intercept, which I called my base. Then we have pi 3, which is my max. Then it comes back to my base, or my x-intercept in this case. And then it goes to min. So it went min, base, max, base, min. Normally, the cosine starts at max and ends at max. But once again, because of the negative sign, that's why we reversed the pattern. So my first point is at 0, negative 3. Then we have pi over 2, 0. Then we have pi 3. Then we have 3 pi over 2, 0. We have 2 pi negative 3. I'm connecting that. Notice all it did, the negative sign did is kind of reversed or flipped the cosine function. Example 5, we're going to graph y equals negative 3 sine of 1/2 x. This is going to do the same thing. It's going to basically have a reflection for the sign because it has that negative sign in front being multiplied. So the amplitude is going to be the absolute value of negative 3, which is 3. So the max is 3 and the min is 3. The period here is going to change because notice it's not just 1 now. This is 2 pi over that 1/2. And 2 pi divided by 1/2, flipping the fraction, that's 2 pi times 2 over 1, which gives me 4 pi. So now my period is 4 pi. So this time I'm going from 0 to 4 pi, and that's going to be 1 period. For my x values, to find them, we're going to say the period divided by 4. So 4 pi divided by 4. So basically I'm counting by 1 pi. So each little increment is going to be 1 pi. So we're going to start with 0. 0 plus 1 pi is just pi. 1 pi plus 1 pi is 2 pi. 2 pi plus 1 pi is 3 pi. 3 pi plus 1 pi is 4 pi. And now we're going to evaluate that at y equals negative 3 sine of 1/2 x. And once again, you can use a calculator. I'm just working them by hand. So negative 3 sine of 1/2 times 0. So we know it's going to be negative 3. 1/2 times 0 is 0. And sine of 0 is 0. So negative 3 times 0 is 0. So notice we started my base or my x-intercept. The pattern is not switching. Evaluating it at pi, we have negative 3 sine of 1/2 times pi. Well, that's basically sine of pi over 2. So negative 3 sine of pi over 2 is 1. And negative 3 times 1 is negative 3. evaluating at 2 pi, we have -3 sine of 1/2 times 2 pi. Well, that 1/2 times 2 pi is just pi. So sine of pi is 0, and -3 times 0 is 0. Once again, that's my base for my x-intercept. So evaluating at 3 pi, -3 times 1/2 times 3 pi. Well, that's basically 1/2 times 3 pi is 3 pi over 2. So -3 sine of 3 pi over 2. Well, we know 3 pi over 2. Sine of 3 pi over 2 is -1. And so -3 times -1 is 3. Evaluating at 4 pi, so we have -3 times sine of 1/2 times 4 pi is 2 pi. So -3 sine of 2 pi is 0. And -3 times 0 is 0. So notice here that the pattern has reversed because it had a negative sign. So it's the x-intercept, and then we had our minimum. Then we had our x-intercept, which is our base, and then we had our maximum. Then we come back to our base. So I'm going to start at 0, 0. My next point is at pi -3. Then I have 2 pi 0. Then I have 3 pi 3. And then I have 4 pi 0. Now, if you're wondering why my graphs are looking almost the same, is because I'm making each little increment based on what I need. So in this case, every increment or space is 1 pi. So you need to make sure that when you're reading on my math lab, the labeling is correct. Example 6, we're graphing y equals 4 cosine of pi times x. Here the amplitude is the absolute value of 4, which is 4. The period is going to be 2 pi divided by whatever's being multiplied next to the x. In this case, it's pi. So the period is 2 pi divided by pi, which is going to give me just 2. So this particular graph is going to go from 0 to 2. So I'm going to start at 0, and I'm going to stop at 2. So my last x value will be at 2. So to find my each spacing, it's going to be period divided by 4. So in this case, 2 divided by 4 is 1/2. Depending on what I need, I might not simplify the fraction, but it's 1/2. We're going to start at 0. 0 plus 1/2 is 1/2. 1/2 plus 1/2 is 2 over 2. I'm not going to simplify that yet. 2 over 2 plus 1/2 is 3 over 2. And 3 over 2 plus 1/2 is 4 over 2. And 4 divided by 2 is 2. And 2 divided by 2 is 1. Okay, now we're going to substitute that into y equals 4 cosine of pi x. So 4 cosine of pi times 0. So that's 4 cosine of 0. Well, cosine of 0 is 1. 4 times 1 is 4. Notice that is my max. Remember, cosine starts at max and ends at max. So we know we did it right correctly. You can punch this straight in the calculator by typing in 4 cosine of pi times 1/2. So that's 4 cosine of pi over 2. Well, we know cosine of pi over 2 is 0, and 4 times 0 is 0. So there's my base, or my x-intercept. Substituting 1, we have 4 cosine of pi times 1. Well, that's just 4 cosine of pi, and cosine of pi is -1, and 4 times -1 is -4, so there's my min. The next x value is 4 cosine of pi times 3/2, so that's 4 cosine of 3 pi over 2. Well, we know cosine of 3 pi over 2 is 0, and 4 times 0 is 0, so there's my base or my x-intercept again. Then we have 4 cosine of pi times 2, which is 2 pi. So we have 4 cosine of 2 pi, which is 1. So 4 times 1 is 4. So there's my max. So notice it started at max and ended at max. Starting at 0, 4. And then we have each little increment is a half space apart. So then we have 1/2, 0. So it goes high or max, base. Then we have 1, -4, so it goes min. Then we have 3/2, 0. Then it goes back to base. And then we have 2, 4. So it goes back to max. And then connecting your points. And once again, I want to make sure you understand that this pattern will continue for the next period. So this period was from 0 to 2, so the next one will be from 2 to 4. And I can also go the other direction and go from -2 to 0. Example 7, we're going to graph y equals 3 sine parentheses 2x plus pi over 4. So here the amplitude is the absolute value of 3, which is 3. The period here is going to be 2 pi divided by 2, which is pi. The phase shift, which notice this particular problem has a phase shift, is always going to be c divided by b. So here c is pi over 4. B is 2, so pi over 4 divided by 2 will give me pi over 8. My increment here will be the period divided by 4, so it's going to be pi over 4, so I'm counting by pi over 4 each time, and we're going to start at right at pi over 8, so that's going to be my first x value, and we're going to add pi over 4 each time. So pi over 8 plus pi over 4, and if I get a common denominator, I'm going to multiply by 2. So we have pi over 8 plus 2 pi over 8 is equal to 3 pi over 8. Okay, so I'm going to go ahead and say that pi over 4 is the same thing as 2 pi over 8, so I can just use that for the next problem. So the next x value is 3 pi over 8 plus 2 pi over 8. That equals 5 pi over 8. 5 pi over 8 plus 2 pi over 8 gives me 7 pi over 8. 7 pi over 8 plus 2 pi over 8 is equal to 9 pi over 8. So my stop was at 9 pi over 8 minus my start is pi over 8, which is 8 pi over 8, which is pi, and that better be my period, which it is, so I know I did it right. So this particular interval is from pi over 8 to 9 pi over 8. That's one period. So now when we substitute, and you can punch this in the calculator or remember the pattern. So to substitute, you're going to say 3 times sine of 2 times pi over 8 plus pi over 4. And remember the pattern for sines should be 0, which is the base or the x-intercept. The next value, 3 sine of 2 times 3 pi over 8 plus pi over 4. That will give me the max, which is 3. The next value, 3 sine of 2 times 5 pi over 8 plus pi over 4. That will give me 0, which goes back to the base. In this case, that's my x-intercept again. The next one, 3 sine of 2 times 7 pi over 8 plus pi over 4. That gives me my min, which is -3. And 3 sine of 2 times 9 pi over 8 plus pi over 4. That gives me my 0, which goes back to the base or x-intercept. So notice when I graph this, I'm going to shift over pi over 8. So I'm going to let each increment just be pi over 8. So I'm just going to say that's pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8 is just pi over 2. Then we have 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8 is pi, and then we have 9 pi over 8. And when I graph this, I'm shifted over pi over 8, so I have pi over 8, 0. Then we have 3 pi over 8, 3. Then we have 5 pi over 8, 0. Then we have 7 pi over 8, -3. And then we have 9 pi over 8, 0. So notice we just moved the sine function over pi over 8. Example 8, we're graphing y equals cosine parentheses 2x plus pi, close parentheses, plus 1. Notice where that plus 1 is. It's completely outside of the function. So that is going to change my base. So my base has always been 0 because I have never been adding something to the functions. But in this case, my base is going to move to 1 because that is being added. So it's going to be a vertical shift up 1 units. It's going to change everything just a little bit. Here my amplitude is the absolute value of 1, which is 1. So my max is 1 and my min is 1. But I also have a vertical shift, so it's going to change that a little bit. My period is 2 pi divided by 2, which is pi. So here I know my x values is going to be counting by my period divided by 4, so it's going to be pi divided by 4. But I have a phase shift here, which is always going to be c divided by b. So my c here is pi divided by my b is 2. So my phase shift is pi over 2. So I'm going to shift over pi over 2 to the right. So my first value will be at pi over 2. So I'm adding pi over 4 each time. I'm going to go ahead and say pi over 2, getting the common denominator of pi over 4 since my increment's pi over 4. So pi over 2 is the same thing as 2 pi over 4, just so that way I have my common denominator already ready. So we have 2 pi over 4 plus pi over 4 is 3 pi over 4. 3 pi over 4 plus pi over 4 is 4 pi over 4, which is pi. And then we have 4 pi over 4 plus pi over 4, which is 5 pi over 4. And my last point is going to be 5 pi over 4 plus pi over 4, which is 6 pi over 4. And I can simplify that to 3 pi over 2. So notice that I stopped at 3 pi over 2, and I started at pi over 2. 3 pi over 2 minus pi over 2 is 2 pi over 2, which is pi, and that is my period. So I know I did this correctly. Now, how does this graph change? Well, that +1 is going to change a little bit of my max and min, okay? So how does it change? Well, my amplitude is 1, so now normally my max would have been 1, and my min would have been -1. Well, now because of this +1 being added, my max is going to be that +1, so it's going to be 2, and my min is going to be at 0. That's how my max and min changed. You don't even have to worry about that. You can actually literally just use the calculator and substitute, or you can do it by hand. So here I have cosine of 2 times 2 pi over 4 plus pi plus 1. So here I have basically 2 pi over 4 times 2 is like 4 pi over 4, which is just pi. And pi plus pi is 2 pi. And cosine of 2 pi is 1. And 1 plus 1 is 2. So you can punch this straight in the calculator, or you can evaluate it like I did. But notice that cosine always starts at the max and ends at max. So next we're going to plug in cosine of 2 times 3 pi over 4 plus pi plus 1. You should get 1, which is my base. Then we have cosine of 2 times pi plus 1. That should give you your min, which is at 0. Then we have cosine of 2 times 5 pi over 4 plus pi plus 1. That gives me back my base, which is 1. And my last point is cosine of 2 times 3 pi over 2 plus pi plus 1. That will give me my max, which is 2. So when we graph this, we have my phase shift, which is pi over 2. But I'm going to count by 2 pi over 4. So I'm going to count by pi over 4. So this is pi over 4, 2 pi over 4. And I only do that to keep the spacing more equivalent. Okay, so my first point is at 2 pi over 4, 2. Then we have 3 pi over 4, 1. Then we have pi 0. Then we have 5 pi over 4, 1. And then we have 6 pi over 4, 2. So notice I started at max, ended at max. And I just moved up 1 unit.